Hello everyone, welcome to our channel GEMLABs. In our previous video, we have discussed about monitoring room temperature using DHT11 sensor. In this video, we are going to learn about Fritzing software, installation of Fritzing software, what is NodeMCU, interfacing of electronic components using Fritzing software, and programming concepts. Let us know about Fritzing software. Fritzing software is an open source software where anyone can design their prototype. To understand the Fritzing, it is important to know the concepts behind Fritzing. The concepts are breadboard view. Fritzing can present circuit in breadboard view and makes it easy to visualize how components will fit together and be wired together. Next concept is schematic view. This is the conventional view of the circuit as represented in books. Fritzing has a large library of schematic parts to build up this schematic view. Next one is printed circuit board view. It consists of copper tracks laminated on an non-conducting substrate. This level is necessary to fabricate the PCB for the circuit. The purpose of using Fritzing software is it allows us to design prototypes for various circuits and design corresponding PCBs. One of the advantages of Fritzing software is it is an inexpert electronic enthusiast can design circuits and build PCBs suited to their needs. Now let us see how to install Fritzing software. First, go to Google and type Fritzing software download and select download Fritzing software electro schematics. In that, you can see download Fritzing 0.87b for Windows. After that, it starts downloading. After completion of downloading, click on Show in folder. After that, click on Fritzing 0.87a.pc. After that, extract the file. After the file gets extracted, open the file. It will show the Fritzing. Click on it so that you can start designing your schematics. Now let us know about NodeMCU. NodeMCU is a developed board with an inbuilt Wi-Fi module. It is a basic and cost-efficient board to carry out projects using the Internet of Things. The NodeMCU has an ESP8266 microcontroller unit. The operation of this microcontroller is controlled with the programs used in Arduino, thus making it is very easy to use and also to learn basic IoT projects. This board has an inbuilt 2.4 GHz antenna to receive Wi-Fi functions. This board has 4 MB of RAM and 64 KB of RAM. This operates at 3.3 volts and it is important to operate board at this voltage because if the input voltage is increased, there is a chance of getting damage of few GPIO pins in the board. Coming to the pin description, it consists of 30 pins. VIN is powered up with 3.3 volts and is used to power up the entire microcontroller. GND pin is connected to ground. Reset pin resets the microcontroller and clears the memory. Enable pin is used to enable the operation of microcontroller. 3V3 pin provides 3 volt output and this can be used to power up some sensor units connected to the microcontroller. SD1, CMT, SD0, CLK pins are used in SPI communication. It is used to transfer signals between two microcontrollers, RX and TX modules with asynchronous transmission. SD3, SD2 can be function as asynchronous transmission or as GPIO pins. There are two reserved pins used by the microcontroller and cannot be used in connecting with any external circuits to it. NodeMCU has only one analog pin for analog communication. This pin is used for analog signal communication. NodeMCU has 16 GPIO pins which can be used as input or output based on programming. The GPIO pin 1, 3, 13 and 15 are used for universal asynchronous receiver and transmission. In our previous videos, we have already discussed about what is LED, LCD, LDR, motors and sensors. In this, we are going to see how to interface these components with NodeMCU. This is how schematic of LED with NodeMCU looks like. For interfacing LED with NodeMCU, we are not using Proteus software because NodeMCU consists of inbuilt Wi-Fi module, but Proteus does not have any Wi-Fi module library and hence cannot be added. So we are going to interface it with using Fritzing software, but using this software we cannot check the output. Using this software we can design the simulation part. Now let us see code for interfacing LED with NodeMCU. We have initialized LED of int data type with D1, which means digital pin 1 of NodeMCU is connected with LED and made LED to behave as output and made LED to be high for 1 second and low for 1 second. Now let us see how to interface it. First go to Fritzing software. In that first select breadboard. After that select search. In that type LED so that it will show the list of LEDs available. In that select the LED which you require and place it on breadboard. Now in search type NodeMCU and place it on breadboard. Now type resistor in search and select the resistor and place it on breadboard. Now connect 3v3 pin of NodeMCU to positive and GND pin to ground. Now place the resistor to anode terminal of LED and connect D1 pin of NodeMCU to cathode terminal of LED. After completion of giving connections, go to Arduino IDE and write code for LED interfacing with NodeMCU. If you want to upload the code, first we should go to Tools. In that we should select Board. In that go to Boards Manager. In that type ESP8266 so that you can see ESP8266 community. There you can select the version you want and click on install so that it gets installed. Now again go to the tools and in that select board. In that select ESP8266 boards of 2.7.1. In that select generic ESP8266 module. Next one is LCD. This is how schematic of LCD with NodeMCU looks. Let us see code for LCD interfacing with NodeMCU. First we have included the liquid crystal library for LCD and assigned RS, EN, D4, D5, D6, D7 of const int data type with D6, D5, D4, D3, D2 and D1. Here we are taking 16x2 LCD display and have displayed welcome to and positioned the cursor at 0th row and first column and displayed the GEMLABs. Now let us see how to interface 16x2 LCD display with NodeMCU. First go to Fritzing software and select breadboard. In that select search and type LCD. In that select 16x2 LCD display and place it on breadboard. Now type NodeMCU in search and select it and place it on breadboard. Now type pot and select pot and place it on breadboard. Pot is used to control the LCD brightness. Now connect VDD pin of LCD to positive and VSS pin of LCD to ground and connect 3.3V pin of NodeMCU to positive and GND pin of NodeMCU to ground. Now connect pot VCC pin to positive and GND pin to ground and connect RS pin to pot and connect D4 pin of NodeMCU to D4 of LCD and connect D3 of NodeMCU to D5 of LCD. D2 of NodeMCU to D6 of LCD and D1 of NodeMCU to D7 of LCD and go to Arduino IDE and write code for LCD interfacing with NodeMCU. Next one is LDR. This is how schematics looks like. Let us see code for it. We have assigned LDR of int data type with A0, which means analog pin of NodeMCU is connected to LDR, and assigned LED of int data type with D1, which means D1 pin of NodeMCU is connected to LED, and made LDR to behave as input and LED to behave as output. In loop, we have assigned analog read of LDR to LDR val of int data type and mapped analog values and digital values. Now let us see how to interface LDR with NodeMCU. First, go to Fritzing software. In that, select breadboard. In that, select search and type NodeMCU and place it in breadboard. Now type LDR in breadboard and place it in breadboard. Now type resistor in search and select resistor and place it near LDR on breadboard, and again place resistor on breadboard, and type LED in search and place it on breadboard near resistor terminal, and connect 3v3 pin of NodeMCU to positive and GND pin of NodeMCU to ground. Now connect LDR one terminal to positive and another terminal to resistor and A0 pin of NodeMCU, and connect another terminal of resistor to ground, and connect D1 pin of NodeMCU to cathode terminal of LED, and connect LED anode to resistor terminal. After completion of giving connections, go to Arduino IDE and write code for interfacing NodeMCU with LDR. Next one is ultrasonic sensor interfacing with NodeMCU. This is how schematics looks like. Let us see code for it. We have assigned D1 and D3 of trip pin and echo pin of int data type, and taken variable of duration and distance of long and int data types, and made trip pin to behave as output and echo pin to behave as input. In loop, we have made trip pin to be low for 2 microseconds and high for 2 microseconds, and again made it as low, and assigned pulse in of echo pin to duration, and assigned duration into 0.034 by 2 to distance for calculating distance based on sound velocity, and printed the value of distance. Now let us see how to interface ultrasonic sensor with NodeMCU. First, go to Fritzing software and select breadboard. In that, select search and type ultrasonic, and select ultrasonic sensor and place it on breadboard. Now type NodeMCU and place it on breadboard. Now connect VCC pin of ultrasonic sensor to positive and ground to ground, and connect D1 pin of Arduino to trigger pin of ultrasonic, and echo pin of ultrasonic to D3 pin of NodeMCU. After completion of giving connections, go to Arduino IDE and write code for interfacing ultrasonic sensor with NodeMCU. Next one is DC motor interfacing with NodeMCU. This is how schematic looks like. Let us see code for it. Here we have assigned D1 and D2 to IN1 and IN2 of int data type, which means D1 pin of NodeMCU is connected to input pin 1 of L293D, and D2 pin of NodeMCU to input 2 of L293D, and made IN1 and IN2 to behave as output. In loop, we have made IN1 to be high and IN2 to be low for 10 seconds, and made IN1 to low and IN2 to high for 10 seconds, which means motor rotates in clockwise direction for 10 seconds and anti-clockwise direction for 10 seconds. Now let us see how to interface it. First, go to Fritzing software and select breadboard. In that, select search and type DC motor and place it on breadboard. Now type L293D and place it on breadboard. Now type NodeMCU and place it on breadboard. Now connect positive of L293D to positive and negative of L293D to ground. Connect DC motor to motor 1 of L293D and connect 3V3 pin of NodeMCU to positive and GND pin of NodeMCU to ground. Now connect IN1 pin of L293D to D1 of NodeMCU and IN2 pin of L293D to D2 of NodeMCU. After completion of giving connections, go to Arduino IDE and write code for interfacing DC motor to NodeMCU. If you have any queries, you can contact with the details provided. Please do like, share and subscribe our YouTube channel. Thank you.